when we talked about identifying functions, okay, I can give you different situations. One could just be a word situation. You look at the input or output. Input. Okay. If I give you a table, you only look at the what values? X. X cannot be repeated. If I give you a graph, it's got to pass the what test? Vertical line. If I give you an equation, you got to solve for. And if you take the square root of something, it's what? Is that a function? No. Okay, good. All right, the next thing was we evaluated functions algebraically. If I said f of 3, you plug 3 in for the what? Variable. Whatever the variable is, okay? Then we learned how to state the domain of functions algebraically.
If you have a variable in the input, it's going to come out as an equation.
Yes, you're right. Like if you have 3x, if it's f of 3x, I mean you take 3x and plug in, you still don't have some variables. Yes. State the domain of functions algebraically. There's two situations we have to worry about, and it's on your quiz tomorrow. What's the first one? If it's in what form? Radical. We can't have less than 0 in the real world. So you take the radical, what's under the radical, and set it what? Greater than or to what? 0. Now, if that radical is in the denominator, you only do what? Greater than. Very good. What's your other thing you have to worry about? Rational. You cannot have 0 in the what? So you set the bottom equal to 0, and those are the values you do not want. Is everybody good with that? Okay, so we did these two algebraically. But once we did these two algebraically, we moved to the graphical side of it. Evaluating functions by using a graph. So if I asked you f of 2, that's the x coordinate, you went and found the y. Do you remember that? Then we stated the domain, the range, the y-intercepts, and the zeros, okay? So right now I want you to get your homework out at page 17. I'm going to come around and check your homework quickly. And we're going to go over that, okay? That's what else is on your quiz tomorrow. It's page 17.
I'll go do it 0 period, but I didn't get it. Is it traffic?
Here in the whole day yesterday, do you have a class that you might have 5 minutes in class that you could have done that homework? In all your classes, all day, is there a class that the teacher might be a little bit more relaxed and you got 5 minutes you can do your homework?
Yes, sir.
Well, what do you choose to do instead of taking advantage of that time?
Just do that at home at midnight.
Was that your conversation? Mine and Derek's conversation. Okay, thank you. I love you, buddy, but don't interrupt when I'm getting on to somebody, talking to somebody. I'm sorry. I'm not getting on to you. I'm just teaching you, but like, hey, here, take advantage of your free time so you don't have to worry about it. You got me?
Yes, sir.
I apologize how I didn't mean to hurt your feelings. I wasn't trying to be somebody else, but I'm just teaching. Don't be getting my conversation, okay? You good? Yes, sir. Okay, thank you. What's up with all these? I love when I can just come around and shake it. I don't know. Because you know Miss Chester loves cheese. You know cheese is my favorite food. If you ever wonder, as long as certain types of cheese. Mozzarella, cheddar, Gouda. Sorry, that's where you're up. Yes, I am. Thank you. Four cheeses. All right. So let's look at number 17, page 17. Let's call these out quickly, okay? What's f of negative 7?
2.
F of negative 3?
4.
F of 1?
Negative 1.
F of 4?
Negative 4.
Okay. Are there any questions on those four? Now I do have a question. What if I ask you this to work backwards? Am I giving you the x value or the y value here? If I say find f of it, what is x if it's equal to 2? That would be your y value, wouldn't it? So I will go up here to where I'm going to find a point. Okay. at 2, right here it clearly crosses that. So x would be equal to -7. Is almost at -2 as well. But I just want to make sure that you understand if it's after the equals, that's your y value, okay? Because you have questions like that on the test. Number 2, what is f of -3? 1. F of -1? 2. F of 2? 4. F of 5? 7. Very good, guys. All right, here we go. It's that identify the domain, the range, the y-intercepts, and the zeros. All right, number 1, what's your domain, guys?
All real numbers.
Very good. What's your range? A bracket around -4 to what? Infinity. Very good. Your y-intercept? Very good. Your zeros?
-3 and 1.
Very good. -3 and 1. All right, number 4, your domain? Bracket 0 to? Very good. Your range? Very good. Your y-intercept? Zeros. Very good. Are there any questions on the first page? Okay. Number 5, your domain? All real numbers, -infinity to infinity. What's your range? Very good. Bracket 0 to infinity. Remember, when you're doing range, you want to find the y coordinate. Don't be tempted to put that -3. That's the x coordinate. What's your y-intercept? 4. Zeros? Very good. Number 6, your domain. Very good. Parentheses, -6, comma, 0 bracket. Okay? Make sure you know your notation. There's no partial credit on notation. Okay? What is range? You said, Mr. Ezra, if I put the numbers -3, 4, but put the wrong notation, I don't get credit? No. You should. It's all or nothing on notation, okay? All or nothing. What's your y-intercept, guys? 0. Very good. Number 7, your domain?
Bracket -7, 6, parentheses.
Very good. Range?
Bracket -4, 5, bracket.
Okay, very good. I'm hearing the same 2 people. I have 31 other people in this room. Now, how much? Let's get a little bit more enthusiastic about this. Okay, y-intercept, class?
-4.
0.
-3. 4.
Very good. Number 8. What's your domain?
Bracket -3, 8, bracket.
Range?
Bracket -3, 4, bracket.
Y-intercept?
4.
Zeros?
-2, 2, 5, 7.
Very good. Are there any questions on your homework? I just love y'all. All right. Oh, we just get so much done. All right. Next, let's review what we learned yesterday. All right. Are we sure? We all good so far? You understand what your test is on so far? Okay. Pretty much we've reviewed everything that's 3/4 star test. All right, now, yesterday, let's just talk about this. We talked about even and odd. I want to put this up here. Okay? Which one goes with even, top or bottom? Okay, let's think about this. If this means I'm plugging in a what? -x. If I plug in a -x, I get the what? Original function, don't I? I plug in the -x, that's a minus right there. That means I get the what type of function? Opposite. Okay, so which notation goes with even? The bottom, okay? You got to know this notation because there's going to be a question on your test. I have a picture. I'm going to say, is this graph a representation of this? If you don't know what this means, you don't know how to answer that, okay? All right. Now, good morning, Ms. Plant. Now, even versus odd. Even has symmetry with respect to the y-axis. If I asked you to prove it graphically, you could pull a point out and then show me a point that has the same y-coordinate but opposite x. Do you see that? Okay. Odd has symmetry with respect to the origin. Pull a point and it has to have opposite points. Now, in even, it has to be in the what quadrants? 1 or 2 or 3 and 4. Okay. In odd, it has to be in 1 or 2 and 4. Okay. we finished everything on this note taker yesterday, didn't we? Okay, let's just make sure we know how to prove this. I'm gonna go back over to number 14 just to make sure you understand how to plug that in. If I was to ask you to prove that, well, right now we can look at that and tell that's going to be what? Even. And even means there's symmetry about the what axis? The y, okay? So I would do this to prove it. Plug in a negative x, that's going to be negative x to the fourth minus negative x squared plus 4. Alright? That's an understood negative 1, isn't it? Okay? So what's negative 1 to the fourth power going to give you? Positive 1. Bring that minus down. What's the negative 1 squared going to give you? Positive x. It's going to be positive x squared, but that minus was there, so I brought it down. Do you see that? Plus 4. Does that look just like what we started with? That's how you prove it. Are we good on that? Okay. Alright. Let's move on to our new notes. We're going to take this and keep going with it. Turn to page 19 in your notebook. We got 3 examples we're going to do today, and then you're going to work on some. Alright. So, we're looking at this graph right here, and first thing we start off with is just reviewing. A wants to know the intercepts, okay? So let's do our zeros first. What's our zeros on this graph? Negative 1 and 1. So our zeros are negative 1 and 1. Our y-intercept is what? 2. Now, before I do the domain and range, remember, I always look at my end behaviors. They're dots, aren't they? That means it doesn't go on and on. So my domain would be from what, class? 3 to 3. Very good. So I'm going to put that in brackets because there's no sign of openness anywhere. My range would be from what? 3. Very good. That's our review. Now we're about to learn some new things. Well, we can skip down to this last part. Is this even, odd, or neither? Even. Because the y-axis is the line of symmetry. Now, if you cannot determine that, I'm going to pick this point right here, 3, 3. If it was even, that means the x-coordinate would be negative 3, and 3 is that there. So can I prove that it's even? Yes. Okay, now this is where we start learning new stuff. So our learning target today is I can determine the domain, the range, the intercepts. We've been doing that, okay? Here's the new part. The intervals of increasing, decreasing, and or constant, the local max, and the local min. Okay, that's our new part, and that's our last part that we're going to learn before our test. Alright, so let's just look at this graph. If you look at this graph, what is happening right here? This is what? Decreasing. And then it does what? Then what? Very good. Where these turning points are, like right here, when it went from decreasing to increasing, and from increasing to decreasing, those are called extremae. No, hold on. Never mind, I just said that wrong. That's the word. Extrema. I think that's how you say that. But that is what's called your local max and min, okay? Those are known as turning points, and those are very important. When you go from decreasing to increasing, those are known as turning points, okay? And that's what's going to be your local max and mins, okay? So, let's talk about increasing and decreasing. Increasing, decreasing, and constant. When you write this, it's going to be in interval notation, okay? And when you write that, you only use your x-coordinates to describe increasing, decreasing, and constant, okay? So it's going to be interval notation. You're only going to use your x-coordinates. And guess what? What do you think goes around them since they're turning points? Parentheses or brackets? Parentheses. Parentheses will always go around increasing, decreasing, and constant. Because at that point, it's either increase or decreasing It's doing a little bit of both because it's turning over, isn't it? So that's why you put parentheses around them, okay? Now, some professors, some teachers say it doesn't matter. I just say parentheses. I like parentheses. So right here, from here to here, I'm decreasing. So from what x values? -3 to, so I'm going to put -3 to -1. I'm increasing from -1 to what? 0. Decreasing from 0 to what? 1. And I'm going to put a union symbol when you have more than 1. And then I'm increasing from 1 to what? 3. You said, Mr. Esther, what do you mean by constant? A constant is a plateau. You see how you see this plateau coming up over here in a minute? That's an example of constant. But we didn't have that over here, so you're going to put, we don't have any. Now, yes, go ahead.
So you just have to put the X's, you don't have to put the points.
Yeah, it's just X's. Yes. Now, that's where it's going to get a little confusing for just a second. Let's remember this. Domain range, increasing, decreasing, that's all interval notation. But local max and local min is an ordered pair. So when you see that ordered pair in local max and min, you want to think, oh, it's an interval notation. No, that's an actual point. So if you want to put, that's an actual point, that's an X and Y coordinate for max and min, okay? That's an actual point. Maxes are like hills, mins are like valleys. Now, I'm going to tell you some things about max and min. Max and mins will not be your endpoints. Will never be endpoints, okay? And max and mins will never touch the plateau. Like on this constant rate, you say that endpoint, mins and maxes will never be part of that plateau, okay? Are we good? Will not be endpoints and will not be part of the constant. Does everybody understand? So in this one, we only have, what would that be considered? Min, that's a valley, that's a what? Max, and that's a what? Min. Okay, so you write the ordered pairs of that. So my min, this first one would be -1, 0. Max would be 0, 2. And then 1, 0. These are ordered pairs, so do I need to put a union node? No, you use unions for interval notation, okay? You use unions for interval notation. These are actual ordered pairs. Okay, does that make sense? We're going to skip 2. I want to go to 3. All right, on number 2 right here. What's my zeros? What's my zeros? Oh, wrong one. Number 2. My zeros are, okay, that's -2.3. Do you see how they helped you out right there? -2.3, 3. My y-intercepts is 1. Okay, I notice for my domain range, these are dots on the end. They do not keep going. So my domain is from what? -3 to 3. My range is from? Very good. Let's skip down here. Is it even, odd, or neither? It's neither. So we start from the left. What's happening with this graph? It's doing what? Increasing. Then it's what? Constant. Then what? Then what? You see how to do that? All right, so from increase, remember, increase is interval notation using only the x coordinates. It's increasing from -3 to -2, union 0 to 2. It's decreasing at this interval, 2 to 3. Decrease using x coordinates. It's constant from -2 to what? Very good. So there's your intervals. Increasing, decreasing, and constant. Now we got to look for our local max and min. Okay, start from the left. Okay, would that be a max? No, because it's part of that plateau. Would that be a max? No, it's part of the plateau. How about that?
Yes.
That's a max. Will these endpoints be anything?
No.
So do I have any min? No, I just have a max. That's it. So my max would be 2, 2.
So you'd have to have a decrease in it. It wouldn't be at end points for it to have a min.
Yeah, endpoints can't be a min. Okay, I want you to do this one on your own, and you can work in your group on this one right here. I want you to do that one, okay? It's called a streamer. I just figured out. I just remembered it's a streamer. Give you about another minute. We're going to go over that one. Yes, buddy.
So your local max, for example, is going to be like the highest point on the graph that's not an endpoint, and your local min is going to be the lowest point.
All right, it's going to be a valley, and the max is going to be a hill. Yeah.
Okay. And it's
Not always the highest point. It just can be where it turns from increasing, decreasing. That's where those points are located. Yeah.
Okay, is it only ever going to be 1 point?
No, it can be more than one max.
Okay. So like on number 1, you would have 2 minimums, 2 local mins?
Mm-hmm.
Okay.
Yep. Yep, 2 local mins. Just remember, max and mins are where it turns from increasing. When it changes direction, you got to identify that point, unless it's the end point. All right.
Why isn't the one with the plateau have?
That's just the rule. If it's part of the plateau, it is not a max or min. That's just a math rule.
So if there were more points in there, then it might have an end. If there's like another point on the end, like add like another line.
Oh yeah, like if it had kept going, yeah, it can have more than one man. Yeah. All right, let's look at this one. All right. What are my zeros here, guys? I only have one. It's 0, isn't it? Okay, my y-intercept is what? 0. Very good. Domain, look at your ends. Negative infinity to positive infinity. What's my range? All real numbers as well. Okay, is it even, odd, or neither? I want to ask you that. Odd, very good. Now I'm going to ask you to prove that to me. algebraically?
Because if you were to take 2 points, they're going to be exactly the opposite.
Okay, so if I pick the point 2, 4, 2, 4, do I have negative 2, negative 4 plotted?
Yes.
That's how you would prove it to me on the test. You got me? And that's why it's odd.
How would you word that on the test?
I would just put, you would put it is odd because both the points 2, 4, and negative 2 and negative 4 are graphed, and in order for it to be odd, you have to have a coordinate and the exact opposite coordinate. Does that make sense? In those own kind of words, it ought to be exact like that. Yes.
Do you want us to do that for all?
No, it's just going to be 1 or 2. It will say, prove to me mathematically. And that's how you prove to me mathematically. Okay? Alright. Now. Okay? Increasing. Okay, now let's talk about this. If I start from the left, I'm increasing from what? Negative infinity to what? Very good. Okay? Then I'm decreasing from negative 3 to what? Negative 2. Then I'm increasing from all the way to what? 2. Then decreasing from 2 to, and then increasing from, yep, I ran out of room. Do you see how that works? Do I have any constant? No. Okay. Remember, max and mins are where they turn. So from here, I'm going increasing, and now I'm decreasing. I got to identify that right there, this right here, this right here, and this right here. So is that a hill or a valley?
That's a hill.
So that's going to be what point?
Negative.
Negative 3 what? 2, yep. Negative 3, negative 2. Then I'm going to have negative 2 what? Now these are ordered pairs, so do I need to put unions or anything? No. Then I'm going to have another heel at 2, 4. And then another valley at what? That's how I answer that.
Is local max and min the exact same thing as extrema?
Yes. That's the name of both of them when you put them together. Extrema. And then types of extrema is local max and local min. You're not going to have one like number 2, but y'all are smart. I just want to see what we can do with this. First of all, is it even, odd, or neither? Neither. Okay. Intercept, zeros. What's my 0? My y-intercept? None. Because, guys, what's happening in this graph right here? You remember asymptotes last year? It's going very close to the y-axis, but never touching it. It's going very close to that vertical asymptote. It's never touching it. Okay?
I couldn't tell.
Yeah, that's why I'm going over this one, because it's hard to...
Like normally there'd be a little line.
Uh-huh.
Like if there's a line, if I could see the line, I would definitely know. Oh, it's never touching.
Yeah, because you don't know if it's really going past that y. That's exactly it. All right, so your domain. Okay, your domain. It's not touching the y-axis. So what would be your domain?
It'd be
0 to parentheses 0 to what? Infinity. It's getting very close to 0, but it keeps going and going. Starting from the bottom, my range would be what? Negative infinity, and it goes up to what? 2. Or is that 1 point? That's 1.5. And since it never touches it, what goes around the 1.5? You're right. Like he just said, Tyler said, isn't the whole graph increasing? Yes. So it's increasing from what's my x coordinate? 0 to infinity. It's never decreasing. It never went constant. Do I have any local max or min? No. Okay, you have 10 minutes to work on your homework problems. You have 7 homework problems. It's page 23, 1 through 8, omit 7. Now, 1, 2, and 3, guys, you got to list all the parts. If you don't have enough room there, you might need to do a sheet of paper. That's like what you just did, 1, 2, and 3. And then 4, 5, 6, and 8 are what we did yesterday, even, odd, or neither. Now, yes, you can look at it and tell me if it's even, odd, or neither, but you got to prove it to me, okay? That's your homework. Good class today, guys.
Yes, bud.
Now, once you finish, if you finish early,